We will learn everything about solutions of inequality and how to graph them and how to solve linear inequalities and how to solve inequality applications.
Solving inequalities, logical evolution. We will look into equations first, and from equations we will develop idea about inequalities, and then we will compare how to solve equations and how to solve inequalities. For inequalities, very important is to show proper solutions, and you will be surprised because linear inequalities have several types of notation, and this is what we are going to develop on the next slides.
Short review. If we have three symbols, one symbol is symbol equal and two symbols of inequality. Now, if we have two expressions and they are equal, then we call this an equation. And here is example: x and positive 1, one expression, and 3 is second expression. And if for some reason that they're equal, we call this an equation, and we can read this as positive 1x and positive 1 is positive 3. Now, if we have two expressions and one of them greater, in this case it's x and positive 1, then we can read this as positive 1x and positive 1 is greater than positive 3. This is inequality. Or right side can be greater than left. So we can read as positive 1x and positive 1 is less than positive 3. This is inequality. Now modeling. If we have two baskets and each basket has 3 apples, then we can say that this basket on the scale and scale is on balance. If we place 2 red apples by x, then we will have an equation x and positive 1 equal 3. Left side equal to right side. Balance. And x is 2. X replaces 2 apples to keep balance. So x is exactly 2, not more, not less. We have only and only one solution for equations. Now modeling. If we have two baskets and each basket has 3 apples, then we can say that this basket on the scale and scale is on balance. If we place 2 red apples by x, then we will have an equation x and positive 1 equal 3. Left side equal to right side. Balance. And x is 2. X replaces 2 apples to keep balance. So x is exactly 2, not more, not less. We have only and only one solution for equations. Now checking. If we replace x by 2 apples, our baskets on balance, or we can do this algebraically, replacing x by 2 and then 2 and positive 1. Is it 3? Yes. So this is one solution. We can say x is 2 is a solution. It's only and only one solution for an equation. Now let's move our two baskets to the right. And scale is on balance. And now let's add more apples to the left basket. So our scale is out of balance because left side is heavier than right. Now if we replace 3 red apples by x, now we have inequality. X and positive 1 is greater than 3. We can use our bird and it will help us to read. X and positive 1 is greater than 3. Left side is greater, heavier than right side. So x is 3. Now checking. Let's replace x by 3 apples and we restore previous situation where left side is heavier than right. Algebraic checking. We replace x by 3. Now 3 and positive 1. Is it greater than 3 or not? Sure, 4 is greater than 3. Now we can say x equal 3 is a solution. Now let's add one more apple to the left basket. Now we have 4 red apples. So left side is heavier than right side. Now let's replace 4 red apples by x, and now it looks like x equals 4. Checking. Let's replace our x by 4 apples. As you see, right side is lighter, or we can say left side is heavier. And now let's check algebraically, replacing x by 4. 4 and 1. Is it greater than 3 or not? Sure it is. So we can say that x equal 4 is a solution. Now if we add one more apple to the left basket and left side is still heavier than right side, so it looks like x is 5. Or we can add one more apple and then x would be 6 or 7. And we can continue to add more and more apples, and situation is always the same. Left side is greater, heavier than right side. Even we can take one apple, take a good bite, and return what is left over. And as you see, x can be whole number or x can be a fraction, or we can say what is left over after apple. Now we can come to a very interesting conclusion. Equation has one solution. Inequality has many, many solutions. Now algebraic approach. Here is an equation x and positive 1 equal 3, and if you move positive 1 from the left to the right, we will have negative 1 on the right, simplifying, and x is 2. X equals 2. Checking. If x equals 2, is it solution or not? Replace x by 2 and check is left side equal to right side or not. Yes. So x is 2 is a solution. Equation has one solution. Now, how can we show this solution on real number line? Just like a dot, we have to show point at 2. This is our solution for an equation. Now let's talk about inequality. X and positive 1 greater than 3. And bring positive 1 in order to solve inequality from the left to the right. On the right it will be negative 1, And we can simplify positive 3 and negative 1 is just positive 2. Now how can we read this? X is greater than 2. So here is our bird. So as you see, X is greater than 2. So now let's check what can work and what would not work. Is 3 greater than 2? Yes. But now let's check if X is 3. Is it solution or not? Replace X by 3 and then 3 and 1. Is it greater than 3? Yes. So now we have a solution. And how can we show this solution? We can show as a dot on a real number line. We check integers. Now check rational number in decimal notation. Is 2.1 greater than 2? Sure. If X is 2.1, would it be a solution of inequality or not? We have to replace X by 2.1 and check. Is left side greater than right? Yes. But 2.1 is a solution and it's very close to 2. Now let's check number 2. Is 2 greater than 2? Not really, because 2 equals 2. 2 equals 2, and we have to use parentheses to emphasize that any number which is just a little greater than 2 would be a solution, but not 2. So parenthesis tells us that our solution does not include 2. Now let's talk about equations and inequalities. As you see, equation, this particular one, has only one solution, x equal 2, single solution. An inequality says x is greater than 2. So any number which is greater than 2, just a little greater or more than 2, much more, will be a solution. So if we show all of those numbers on real number line, then we will see millions, billions, infinitely many points. And those points, those solutions, they can stay so close to each other that we would not see openings. This is why instead of showing point, we can show solid line. And each point on this solid line is a solution for inequality. Inequality has infinitely many solutions. I want to use modeling for word set. Imagine that you have a huge bucket with curly handles to hold it, and this is what we would call set. This bucket we use to keep our answers in different colors, in different forms. Now curly parentheses, and we have different forms, different notation for different answers. So we can keep answer as a negative 3, or it can be x equal to 3, or it can be inequality x is greater than negative 3 and less than positive infinity, or it can be x is less than positive 3, or it can be inequality x is greater or equal to negative 3 and less than 3, or it can be interval notation. Whatever you have as an answer, you can put into curly parentheses, because curly parentheses means set, to keep our answers. Now, if you have curly parentheses and variable with slash, it can be x or y or something else. Then, variable x emphasizes that your solutions are changing for x from negative 3 to positive infinity. And if it's y, then your solutions for y are changing from negative 3 to positive infinity. In previous slides, we solved inequality and we got the answer. solution set for that inequality was x supposed to be greater than 2. And now we are going to learn how to show different types of notation for this answer. It can be as a graph from 2 solid line to positive infinity, and you have to show parentheses at 2 because x supposed to be greater than 2, not equal. Or equivalent can be open circle and then solid line to positive infinity, and parentheses and open circle means that solution set does not include 2. Any number which is greater than 2 can be a solution, but not 2. Inequality. You have to show the smallest number on the left, the largest number on the right, and variable supposed to be in the middle. In this case, it's x. And our birds can help you to read. X is greater than positive 2 and less than positive infinity. Set builder notation, we can just copy inequality, and then interval notation, it's coming from our graph presentation, because you see at 2 you can see parentheses, so here is parentheses 2 comma, and then right end is positive infinity. Your set of project number 1 is on the next slide after demonstration. Click and show in order to work on your project after demonstration. To see demonstration on the next slide, click play on the bottom of the screen to begin viewing demonstration for set of project number 1, type of notation. All projects you have to do manually. This is why before you start your project you have to click and show and follow directions. This is demonstration for project number 1. What we have here? We have request show all types of notation for x greater than -1. Before you will show all types of notation, try to focus on the request x is greater than -1. So it's greater than -1, but as always it's less than positive infinity. It's greater, not equal. This is why first we have to show greater than -1. So it will be parenthesis. Okay. And then it can be open circle. Parenthesis and open circle, the same idea. Now, inequality. We always have to read from x. X is greater than -1 and less than positive infinity. Look into our option, and this is 1. Let's move. Set builder notation require the same inequality. We just can copy. Interval notation. We're supposed to have parentheses from the left and from the right. Here. And reading. X is greater. Oops. We have to undo when something like that happens. So now x is greater the -1 and less, it's always less than positive infinity, because we don't know where infinity is. Now, for example number 2, let's practice types of notation for x less than 2. How can we show the solutions? It can be on a real number line as a graph. We have to use parentheses to show that our solution does not include 2. And then solid line from this piece of parentheses to negative infinity. Or equivalent presentation, open circle, and solid line which is going from open circle to negative infinity. It can be shown as inequality. X is greater than negative infinity and less than 2. It's always supposed to be this way: the smallest number on the left, the largest number on the right, and x is in the middle. So x is greater than negative infinity and less than positive 2. Set builder, we just need to put our inequality into set builder bucket. You remember about this? And interval, we have to use parentheses from both sides because we can't reach negative infinity. So solution set does not include negative infinity because no one knows where negative infinity is. And our statement says that x is supposed to be less than 2. This is why we have to use parentheses to emphasize that x is not equal to. Modeling from real life. If you're in airport, you know that your luggage supposed to be 55 pounds or less than 55 pounds. And if you are in Oregon and you want your driver's license, your age supposed to be 17, or you have to be older than 17. All of these requests are coming from real life. Similar situations occur when we want to combine equation and inequality. So we have to combine their solutions, and we have to combine solutions on a real number line. And to emphasize this time that x can be greater or equal to, we have to use bracket. So this way we can emphasize that x can be greater or equal to. We solved inequality in problem number 3 and we got a solution. X is greater or equal to, which means x can be greater than 2 and x can be equal to. Now, how to show this? As a graph, we have to use bracket because bracket tells us that we can include 2 in solution set, and then solid line from bracket to positive infinity. Or equivalent, it can be circle, but this time it's supposed to be filled up. That means we can include 2 in our solution set. And solid line is moving from filled up circle to positive infinity. Inequality, we have to show smallest number on the left, largest number on the right, and variable, in this case it's x, is between. Now birds helping us to read. X is greater or equal to and less than positive infinity. Next, set builder notation. You just need to copy inequality and then interval notation. On the left, we're supposed to show bracket and then 2, comma, positive infinity, parentheses. We have to use bracket because we include 2, and we have to use parentheses around positive infinity because no one can reach positive infinity. No one knows where positive infinity is. This is why we're supposed to use parentheses, always for positive and negative infinities. Similar situation occur if you would have inequality positive 1x and positive 1 is less than positive 3. So we have to combine equation and inequality, then we have to combine their solutions, and combination on real number line will show us bracket and then solid line, which is going to negative infinity. Type of notation for x less or equal to. As a graph, we have to show bracket, and bracket means that our solution does include 2. We can use 2 as a solution for this inequality. And then solid line, which is moving from bracket to negative infinity. Or equivalent presentation, but this time it's supposed to be circle, which is filled up, and then solid line, which is going from this circle to negative infinity. I want to emphasize that bracket or circle which is filled up show that our solution include positive 2. Inequality. X is changing from negative infinity, as you see, to positive 2, and we have to include positive 2. This is why we have to show x is less or equal positive 2. From the smallest to the largest. And our bird can help us to read. So x is, we have to start always from the x. X is greater than negative infinity, and x is less or equal positive 2. Set builder. We just need to show inequality in cell builder length and then interval. We have to use parentheses around negative infinity because we can't include negative infinity into solutions because no one knows where negative infinity is. But positive 2 is supposed to have bracket because we have to include positive 2. We want to emphasize that positive 2 can be a solution of inequality. In your textbook, you can read that solving a linear inequality includes the same steps as we use to solve a linear equations, with one exception, which is very important. Whenever you multiply or divide it by a negative number, you must flip the sign. You don't have choice. You must flip the sign if you, for some reason, have to multiply or divide by a negative number. Now, more formal approach. If we have two numbers, negative 2 and positive 4, positive 4 is greater than negative 2. Now, if we decided to divide both sides of inequality by negative number, for instance by negative 1, what we will have, negative 2 divided by negative 1 results is positive 2, and then positive 4 divided by negative 1 will be negative 4. Now we have to compare two numbers, positive 2 and negative 4. Which one is greater? Positive 2 is greater. As you see, division by negative number results into flipping the sign of inequality. And this has happened because of nature of real numbers. This is every time when you have to divide it or multiply by negative, you must flip the sign. Problem number 3. We have an equation and inequality. And we are looking for 1x for equation and for 1x in inequality. And how can we get this? We have to divide it by negative 2, both sides. So positive 1x is just negative 3 because 6 divided by negative 2 is negative 3. 1 point. Now, the same action towards inequality. We have to divide it by negative 2. By negative, remember, very special. Now, negative over negative gives us positive 1x, and then 6 divided by negative 2 would be negative 3. Now let's talk about symbol of inequality. Because we divided by negative, we have to flip symbol of inequality. And now we have to show on real number line infinitely many solutions from negative 3 to negative infinity. And then checking for equation, we have to pick exactly what we have. X is negative 3. We have to replace x by negative 3 and check is it true or not. Yes, it's true. This is the solution. X is negative 3. One solution for equation. How about inequality? For inequality, we have infinitely many solutions. So we can pick any number from negative infinity to negative 3. Only we are not supposed to use negative 3. I decided to use negative 4. So if x is negative 4 and I replace x by negative 4, the question is left side larger than, greater than right side or not? Let's check. Negative 2 times negative 4 would be positive 8, and positive 8 sure is greater than 6. Yes, so 8 is a solution. And now we have to say all numbers from negative infinity to negative 3, their solution for this inequality. Only and only one restriction. We are not supposed to use negative 3. One more time. Inequality has infinitely many solutions. All numbers from negative infinity to negative 3 will be solutions. And we pick one of them just to check will it work or not. And as you see, it was. Practically, if you have an equality, you have to take the same actions as you would take to solve an equation. Here is an example, negative 2x greater than positive 6. In order to have one positive x, we have to divide it by negative 2, both sides. As a result, we will have on the left positive 1x, on the right 6 divided by negative 2 is negative 3. But this is inequality, and if you have to divide it or multiply inequality by a negative number, you have to flip the sign. This is why we have to flip the sign, and the result is positive 1x is less than negative 3. We can show from negative 3 to negative infinity, and then we can pick any number within this range to check will it work or not. I pick negative 4. So negative 2 times negative 4 would be 8, and 8 is greater than 6. Yes, this range of solution works. So now we can show the answer. Set builder notation and inequality x is greater than negative infinity and less than negative 3. Next example. Positive 3x is greater than negative 6. We are looking for 1x for positive 1x, so we have to divide it by 3, as we would do if we have to solve an equation. Let's divide it by positive 3, so we don't need to change or flip the symbol of inequality. So x would be greater than negative 2, because negative 6 divided by positive 3 is negative 2. Now we have to show on real number line all numbers which are greater than negative 2 and less than positive infinity would be solutions. And for checking, we can pick any number. I prefer to use something small. If x is negative 1, then 3 times negative 1. Question, is it greater than negative 6 or not? Negative 3 is greater than negative 6. Yes. So now solution set. How can we show? You can use set builder notation, curly parentheses, and within curly parentheses we can show interval from negative 2 to positive infinity. Problem number 5. We have an equality. Positive 1x and positive 15 is greater or equal positive 18 and positive 3x. We are looking for x. First we have to separate terms with variable and constant terms. So let's move positive 15 from the left to the right and positive 3x from the right to the left. As a result, we will have negative 3x and positive 1x greater or equal 18 and negative 15. Now let's simplify, because now we have like terms on the left and like terms on the right. Negative 3x and positive 1x will be negative 2x, and positive 18 and negative 15 is just positive 3. And we are looking for 1x, but we have negative 2 times x. We have to divide it by negative 2 both times, and the result would be negative 2 divided by negative 2 will be positive. But when you divide it by negative 2, remember, we have to flip the sign. So greater or equal will be changed into less or equal. So now we have x, or positive 1x is less or equal negative 1.5. Or we can show in set builder notation x is greater than negative infinity and less or equal negative 1.5.